All right, we are on to 3.3, actually not 3.2, 3.3. Congruent figures. So congruent figures are figures in which corresponding angles are congruent and corresponding sides are congruent. So, for example, we have two triangles here, a little bit blurry. But if you gotta look at the markings here, so let's start with the sides. So I'm gonna start with side. Oh boy. Side GI. Because that's my side with one bar here to mark it, is congruent to side MO. Okay, and then I have GE and MQ are congruent. That's what those two bars are telling you. And then third, EI and QO. Excuse me. EI is congruent to QO by those three bar markings. Okay, also we can say that the angles are congruent, so we'll start with I and O because they just have one arc there. So angle I is congruent to angle O. Then we can say angle G and angle M are congruent. And last but not least, we have three arcs here, three arcs there, so E and Q. Okay, so congruent figures are just figures where all the sides and all the angles are congruent. So, are the triangles congruent, and how do you know? So, maybe the easiest way is just to list the angles, list the sides, and see if we got all six the same. So, start with the sides. Okay, I see, boom, I see LM is congruent to KN or NK, whichever way you want to write it. Excuse me. I also see two bars here telling me that KL and MN are congruent. Actually, I'll go MN is congruent to KL. Okay, and then I need a third side. Now here is my third side. NL. And if we're looking at the two triangles, maybe I should have pointed that out first. We're looking at these triangles here. So this one up top and this one down here. So we're looking at these two triangles. So I need that third side. So in this example, the third side is where they overlap. So I need to say that this side, LN, is congruent to NL. Or LN, however you want to write it. So I can say that because it's the same side. I can say that LN is congruent to LN. And if you remember last week, we could say that because of the reflexive property. Okay, because it's just itself. And if something's equal to itself, then we're good to go. Okay, and then the angles. We can do the angles really quickly here. But, so you got to be careful when you name these now. You can't just use one letter. Because angle N, for example, angle N could be here or it could be here. So we got to use three letters. So we'll say KNL, angle KLN, goodness, KNL is congruent to angle. So now we got to start with MLN. Okay, there's the one arc. The second arc, we can go KLN. KLN is congruent to angle MNL. And the third one, a little bit easier to see the third one maybe. But we can say angle, oh my goodness. We could say angle NKL is congruent to angle LMN. So, therefore, we can say the two triangles are congruent. So then we're going to write something called a congruence statement, which is just stating that triangle. Now, I'm going to start with N, L, K. So I just kind of looked at the angles. I mean, you can start with any letter you want, but you have to get them in the right order. So I went from my one arc to my two arcs to my three arcs. So 1, 2, 3. To get a triangle NLK, I have to do the same thing for the other one. So I have to start with my one arc is L, my second arc is, my two arcs is N, my third arc is M. So the order of the letters for your congruent statement is important. Like I said, you have to match up the angles so that the angles and sides match up. All right, one more example here. So again, we'll start with the sides. And again, really quickly, we could say DG is congruent to HF. And then we have DE. So I'm starting with the left triangle. I'm starting everything over here. And then I'm getting the congruent segment from the second triangle. So DE is congruent to HE. And then last but not least, we could say that GE is congruent to FE. So hey, we got all three sides. Okay, now let's talk the angles. Okay, starting with my one arc, I will go FHE. Actually, nope, I said I'll start with the other triangle first, so let's do that. Let's go GDE. Angle GDE is congruent to, so I went from the two arc, so FHE. Should have the little angle symbol in there. Okay, so that takes care of my one arc and the second arc. So we can go DGE is congruent to angle. So I went from 1 to 2 to E. So HFE. Now, I don't see three arcs in there, but I can tell you that this angle is congruent to that angle. And hopefully you would remember that is because they are vertical angles, and vertical angles always are congruent. So you can see that these things are coming back from Unit 2. So last but not least, I'm going to go start from one arc, DEG is congruent to angle. Start with one arc again, HFE. Oh no, I went the wrong way. HEF. So again, we can say that these triangles are congruent. We have all 6 parts, all 3 sides, all 3 angles. So we can say triangle. Now again, it doesn't matter where you start. I like to just follow the angles. So I'll go DGE. So that triangle there. DGE. So one arc, 2 arcs, and then where my third arc was. And I'm going to do the same thing, HFE, just so I make sure that the letters line up properly. So there's my congruence statement. I don't know why this didn't get in this section, but also in this section is some triangle congruence shortcuts. So there are 5 ways to prove that 2 triangles are congruent without having to show every single side and every single angle. You can see it can take a little bit of time. So what we have is, oh my goodness. The first one is side, side, side. So if you know that all 3 sides of 2 triangles are congruent, you know the triangles are congruent. You can just assume that the angles are. The second one is side, angle, side here. So if you take a look, the key with side, angle, side, or SAS, here are your shortcuts to writing them if you don't want to write them out all the time. The key here, though, is that the angle is in between the 2 sides. So you have side 1 congruent to side 1, and you have side 2 congruent to side 2, but then you have this angle in between the 2 sides made up by those 2 sides. And that has to be there so you get side, angle, side. The third one is angle, angle, side. So here you just have 2 angles in a row and then a third side kind of right after. So we got angle, angle, side, angle, angle, side. We also have, so there's the shortcut AAS for angle, angle, side. We also have angle, side, angle, which means now it's very similar to side, angle, side, of course. But we have an angle, a side in between, and then another angle. Angle, side in between, and then another angle. Let's go back up and write all of these. Side, angle in between, side. So you see SAS, side, angle in between, side. And then the last one is hypotenuse leg. Now this only works for right triangles, only. So if you don't have a right triangle, don't even worry about hypotenuse leg. But if we know, where is it? The hypotenuse is the side opposite of that 90-degree angle. It's the longest side of a right triangle. If the hypotenuse side, I don't know the plural form of that actually. But if they are congruent and then you have another side, which we call the legs of a right triangle, you know that those 2 triangles are congruent. So 2 ways that don't work. You cannot go angle, angle, angle. So if I just have 2 triangles and I go something like this, that is not enough. I know all 3 angles are congruent, but that's not enough to know that the triangles are congruent, because believe it or not, the sides can be different lengths, but the angles are still congruent. And then the other one, side, side, angle, or I mean, you could flip it around, but we'll go side, side, angle. So if I just have 2 triangles here, and I'm telling you that this side and that side are congruent, that side and that side are congruent. Now, if I gave you this angle here, we would have side, angle, side. But I'm not giving you that angle. I'm going to give you, let's go this angle here and this angle here. Okay, so if you follow the triangle, we have side, side, angle, side, side, angle. That's not enough either. The angle has to be in between the 2 sides in order for it to work. So there you go. That's everything from section 3.3.